Hi, ladies and gentlemen, here we go. We've got the 2017 AP, number one. This question has a graphing calculator allowed, so I have my graphing calculator with me. I don't have the light on right now. Let me turn it on for a second here. On my graphing calculator, when I'm ready to start any document, or any question, I'm going to make a new document. I'm going to add a calculator page. Control plus doc. I'm going to add a graph page. I'm going to double check to make sure I'm in radiant mode, which I am for all my problems. Here comes the light back on. All right, let's take a look at this problem right here. They've given me a table of data, which I have redrawn on this page right here, and I'll read the information to you. It says there's a tank that has a height of 10 feet. The area of the horizontal cross-sections, meaning they're cutting the tank horizontally, is given by the function above. So at the height of the tank, it's telling me what's happening to the square, not the square footage, but the area. Well, the square footage, the area as the tank goes. So when the height of the tank is 0, the base is 50.3. It's not necessarily square. I'm just putting it down to look like that. When you come up to 2 feet high, it's 14.4. So that area is shrinking. And then as you come up to 5, it's 6.5. Even higher, it's 2.9. That just means I don't know exactly what the tank looks like, but it must be something that the volume is getting smaller. Ooh, it's not actually a good picture. It's probably more like this. That the volume is still increasing, but the square area is getting smaller as you go up and up and up the tank. The particular shape doesn't matter. I just wanted you to have an idea of what to think about with it. The function a is continuous and decreases on a as h increases, which is what I said. As the height goes up, the volume gets smaller. And it's giving me selected values for the area at given points in time above. I'm not sure what the problem is going to ask. I can almost guarantee they're going to ask me to find the area. Here, they're either going to ask me to use left Riemanns, which is rectangles, right Riemanns, or trapezoids. Let's see what they ask. It says on part A, which you should have your packet out with you, it says use a left Riemann sum with 3 subintervals to approximate the volume and indicate units of measure. Okay, so I'm going to look at my data here. From here to here would be rectangle number 1. From here to here would be rectangle number 2. And from here to here would be rectangle number 3. So for this problem right here, the area would be, not the area. It's a volume equation. I'm going to find the integral from 0 to 10. Of a of h. This part wouldn't have to be written down like this, but I know that's what I'm looking for. And so I'm going to do the Riemann sums. The first one is 2 units long. And I'm doing a left Riemann sum. If you're not sure how it's going to look, draw yourself a quick dot. 50.3. At 2, it's at 14.4. At 5, it's at 6.5. And at 10, at 2.9, and we're doing left Riemann sums. We're taking the height. Oh, come back here, pen. From the left side of the graph. So it's that one, and that one. So this one is 2. This one is 3 wide, and this one's 5 wide. So I'm writing them up. The first one is going to be 2 times 50.3, plus the second area is going to be 3 times 14.4. And the third area is going to be 5 times 6.5. The way you can always check in the end to make sure you have the right heights is if we see left, it means we're starting on the left side. We're going to leave off one of our y values. So we used 50.3, 14.4, and 6.5. So we've got those ones all there correct. I'm going to put those in the calculator. Click, click, clickety clack. Clack, clack, clickety clack. And I got an answer of 176.3. Okay, so the area was in square footage. They want the units of measure. This is measuring volume. So we know with any magnitude, we're either going up or down, or we're integrating, we're going up a degree. So instead of feet squared, it's going to be feet cubed. Always going up 1 unit at a time. Okay. The next question says, does this Riemann sum overestimate or underestimate the curve? Explain. Well, I looked at a picture right here. We know the graph is decreasing as time goes by. So if I were to draw a I would say, I already know that the graph is increasing. It's an overestimate. And the answer is why, because I will draw a graph that's decreasing as time goes by. Decreasing. You can literally draw a picture of a left Riemann sum. It'll show you exactly what happens. Let's grab a green right here. Start from the left side. And you can see overestimate. That's enough of a description. You don't have to use words. You just have to show in any way, shape, or form that it is. That's the way I would do it. They're always going to tell you whether a graph is increasing or decreasing. You draw a picture and you draw the sum that goes along with it. Let me just give you a different example. I'll write it in purple. It doesn't go with this problem. Let's say they told me I had an increasing function, which means I would graph it like this. The exact method wouldn't make a difference. What would a right Riemann sum do? All I would do is start on this side of the graph and draw pictures, and you can see for an increasing function, right ones overestimate. That's not part of this problem, so let's cross that out there just so we've seen it. Okay, the next part says, hey, what's that question? The area of the horizontal cross-section is modeled by the function given right here. So that's the area of the cross-section. Based on this model, find the volume and indicate units of measure. Now, I don't think this question will be on the test because they said they're not going to use applications of integration. But if I integrate area, which is squared, it goes up a degree, so I get volume. So all I should have to do is integrate that equation in the calculator, and we should get the right answer. Let's bring our calc in. Let me turn off my little light here for a moment so we don't get the glare. Focus. Okay, I'm going to go to my calculator page, Control plus, and I'm now going to do an integral. Menu, calculus, integral. It's going to go from 0 to 10. And I'm going to put in the function they gave me right here. I'm going to make a fraction. It's 50.3. You can see it in your packet. E to the 0.2h. And I can use h on the calculator. It's fine. Make sure I come down from the exponent. Plus h. And if I used h, I have to put in dh. H. And enter. And I got an answer with a little weird exclamation next to it. It's okay if you end up getting those. The answer I get is 101.3253. So I'm going to write that down for part C. Let it come back on. The volume equals 101.3253. I have to round to the thousandths. 101.325. And do they ask me for units? Units of measure they do. Remember, integrating go up a degree, derivating go down a degree, so it was feet squared was the area. So that means this is feet cubed. Let's circle that. That's the piece right there. On the calculator, if you wanted to graph it and integrate it as well, you could do that. Let's see if I move this over. There, the glare is down. I'm going to put this function in f of x, but when you put it in f of x, you have to use x. That's why I try not to 0.3 over e to the 0.2x plus x. I hit enter. I could see the graph there. Now, this is why they gave it to you like this. Watch this. So if I go menu, analyze graph, if I want to find the integral, lower bound, it asks me where to start, I would type in 0 and hit enter. And if it asks me where to end, I'm going to type in 10. Oh, menu, I'll do it again. Analyze graph, integral. Now it wants the upper bound, 10. Why did it do that? Menu, analyze graph, integral. A little difficult moving it around here. Let's get the lower bound. to 0. I think I saw my technical difficulties. My button was sticking along the way. Also, you may have noticed originally, maybe you yelled at me during the video, I had not typed this in right. For some reason, an extra 3 was in there. But I fixed my function. And to find the area under the curve from the graph, let's see if it works this time. Menu, Analyze Graph, Integral. Lower bound is 0. Hit Enter. It did. Oh, what the? Okay, it worked for me a second ago. Hang on. I'm going to pause this video and make sure my button doesn't extra click again. Hang on. Okay, here we go. Menu, Analyze Graph, Integral. Lower bound is 0. Hit Enter. Upper bound is 10. Hit Enter. And okay, that time worked. And there's the volume right there. My button was sticking as was graphing of water 1.3253, which is exactly what I got before on the problem. If it's a little glarish, let's see if you can see the number. I'll move the number down. It's up in this corner. There. And there you can see the 101.3253. Okay, onward to the last part. Remember, the last part's always the hardest, so if you don't get it, it's okay. Water is pumped into a tank. When the height of the water is 5 feet, the rate of change of height, or the height is increasing at the rate of, which I wrote down, the height is increasing at the rate of 0.26 feet per minute. Find dV/dt. This is using the model from the tank. Find the rate at which the volume of the water is changing with respect to time when the height of the water is 5 feet. So they give me a bunch of information here. They didn't really tell me about the shape of the tank or anything like that, but what they gave me was dH/dt, and they want me to find dV/dt. So let's just take a look at what we have. Okay, so the question here is, what could dV/dt be equal to based on dH/dt? Well, if you look at it, we need to come up with a fraction that will cancel out the h, and dV/dH would be that equation, because if you look, let's see that the h's there would cancel each other out. Okay, so first of all, do I know dH/dt at time 5? Yes, I do. I know that's 0.26. But do I know the change in height of the the change in volume based on height at time t equals 5? So here's where this problem is kind of a stretch to find out what the answer is going to be to find dV/dH. Excuse me, it's always something with d is always going to relate back to early on in the problem. I could find the volume at any point in time of the original equation by integrating starting at 0. I could go to h, whatever height I wanted to go to, of the function that I have up here. And they called that function was a of h. But that function only worked when I had these specific values. Later on, they gave me an equation that gave me area based on height. That means that the volume would also be based on height of that function beforehand, v of x dx. And if I wanted to know what dV/dH was, I would take the derivative. That would be equal to f of h, to drop the top for taking the derivative, at the height I want it to be at. So dV/dH would be the height of the graph at 5. So it would be equal to 0.26 is dH/dt. dV/dt would be whatever that graph is at 5. I put 5 into this equation. And I got 0.26 times 6.517, 0.517, and I got an answer of 1.695. Do they